to the dark side. Well, it's not really the dark side. We have gone a little dark though, insofar as this is about Valve. Well, two valves to be precise. It's a very low cost preamp. It's been around for a few years now, and it's available under various disguises from various distributors in good old China. For that reason, I'm not going to recommend a particular retailer because there are so many, and the variations on the board vary from just a simple printed board and the components and no plugs and sockets, which is basically the one that I have here built. I built it as a kit, and all the parts which they said was there were there, which is unusual. The valves that are supplied are Russian made, and they are a pentode. They are actually connected as triodes. Each valve has one channel, if you like. Most of these kits seem to be supplied with a 6J1 valve, but you could get practically any valve that they happen to have kicking around. In fact, my kit came with a 6J2, which is a very similar valve. Normally valves require quite an extensive power supply, and this is quite a simple version insofar as you need a 12-volt transformer and you actually need AC, so there's nothing else to connect to it except the transformer. It's 12 volts and the actual consumption is about 318 milliamps total, including everything. You could get away with a 500 milliamp transformer. I would use a 1 amp, which means it will run nice and cool. First of all, I'd like to thank Ron, my colleague in America, because we have both purchased, as I always say, with our own money, these kits, and the idea was to get a second opinion. So what you're going to see and hear on this will be a combination of what Ron thought of the preamp and what I thought of it. Neither of us have had virtually any experience with valves for over 40 years. But saying that, I did build a kit which was a 12 watt per channel power amplifier and preamp, and I did this 6 years ago. I won't comment on that at all, other than to say I'll leave a link in the description, so if you've not seen the video you might like to have a look at it. I quite like the product as it happens. I know you didn't expect to hear that, but will I like this one and will Ron like it? That's the question. Now this review is going to be in the usual way, very honest and blunt. If it's not very good, you know I'm going to say so. But I'm not just going to say so, I'm going to prove it. But equally, if we like it, I'm going to prove that as well. You're going to see some distortion figures for a start. All the other figures that go to make up a preamp. Let's get started, and first of all, let's have a look at the board. I'm not going to show you me building it, because once you've seen someone soldering components on a board, there's not much to show, is there? Bearing in mind it is very low cost. The valve that's used in there is a very popular valve because it looks like the Russians have made billions of these valves, and they're basically an RF valve. It's not made for audio at all. I'm not going to make any comment about the valve other than to say is if you were building a low noise audio preamp, you would not use this valve. It wouldn't cost the pennies that it does cost. And whatever else you think about it, it's probably worth building because it was fun. Both Ron and myself both enjoyed building it. Even if you end up never using it, it's fun to try and play about with, and at least you haven't had to spend $300 or $400 just to buy the valves. The volume pot is a linear volume pot. Now normally you would use a logarithmic pot on here. Like many Chinese boards, they've given a linear pot. Ironically, when you test and listen to this, it does seem to follow a fairly good logarithmic law. So on this particular occasion, whilst it's technically wrong, it's okay. The input capacitors and output capacitors are reasonably good quality as well. This resistor here is in series with the heaters and does get quite warm. I mounted this before I'd realised that, but looking at it again, I would probably mount it 1/4 of an inch off the board. They do supply a couple of, I think, blue LEDs which you can put within the valve base and it makes the valve glow blue. Now I think this is just, I don't want to upset anybody, but personally I think it's tacky and I haven't fitted them. But if you want to do that, better still, instead of fitting a blue LED, fit a red LED, and then at least it looks like the valves are lit up. Because I have to say that the valves don't light up very brightly. I've just butted in the video here because I've actually finished editing it and I found its running time was a little bit on the long side. So I've decided to remove the detailed analysis of the circuit diagram and just delete it from the video. I'll put the circuit diagram up for your information, but if you'd like to see on a separate video a full description of the components and what the circuit does and how it does it, please let me know in the comments and I'll be very happy to upload it for you. I'll pop the circuit diagrams at the end of the video for you to have a look at if you're interested. Now on with the video. As per usual, we'll start with our standard 1 kHz square wave. And I have to say that is a very respectable square wave. Here we are at 10 kHz and you can start to see the speed lowering itself, but it's still quite respectable. Here we have 20 kHz, let's open it up, but it's not ringing, nothing really horrible about it except clearly its slew rate is suffering somewhat. Here we have 100 Hz and it's still looking pretty fair. 10 Hz, it's obviously showing its, well, I was going to say relatively poor performance, but for a valve amplifier that's not too bad at 10 Hz at all. The output of this preamp is taken from the anode rather than the cathode. The effect of that is that when you use a standard lead to connect this to your power amplifier, this will happen. Look at this. You can see what's happening. And that is a 200 picofarad capacitor being placed on across the output. And you can see it's slowing the amplifier down as well as decreasing the frequency range. So what does this mean in real terms? The average phono lead of, let's say, a meter will have a typical capacitance of between 2 and 250 picofarad. The cables I was using just now was on a ×10 probe, so effectively has, for all intents and purposes, little effect on the circuit. But when you hang that little capacitor on the output, simulating a standard 1 meter length, you can see what it does to the square wave. And what it's doing, in fact, is changing the slew rate. In other words, the speed of the amplifier. The only thing I would suggest is, when you use this preamp, the leads that go from the output to the amplifier should be as short as possible. And if you can get away with about a foot, that would be what I would go for. But whatever you do, don't get one of these long leads that's about 2-3 meters long, because it will completely destroy the sound of the preamp. As per usual, I haven't bothered to show you the frequency response because it's just a sine wave. Just so you know, 0.5 dB figures, which is my normal way of measuring. 0.5 dB down at the low end is 10 Hertz, so not too shabby. And if you want to go down to 1 dB, it's 6 Hertz, so nothing wrong with that. Nothing wrong with that at all. At the high end, 0.5 dB is 40 kilohertz. Again, not too shabby. And at 1 dB, 60 kilohertz. So pretty fair indeed. Here we've got a sine wave, and you can see that looks symmetrical and quite a nice sine wave. I want to show you now what happens. You're very familiar, I'm sure, with, if you've watched my videos, with what clipping means. And normally, if it's a transistor circuit, this will just square and square here. With a valve amplifier, it doesn't. Let me reduce the gain, and I'm going to turn the gain up now using the volume control on the front. And I want you to look at particular the top here. Now, you won't see it clipping, but you'll start to see about here, it's actually distorting the waveform. Can you see? I think we need to come out slightly. There we go. I've just changed the scope setting. But look at the top of the sine wave. Can you see it's now changing shape? And the fact that the whole sine wave is sort of squashing down. Can you see it? I'm exaggerating it a lot now, and you can see that is really horribly distorted. And that would correspond to about 5 or 6%, and certainly wouldn't be very pleasant or audible. Well, it would be very audible, but very unpleasant. So it's very hard to decide where the maximum output is. Time for some distortion figures. We're going to start out with a very low output of 100 millivolts, and that's probably less than what's going in. So in other words, the preamp is offering virtually no gain. And as you can see, the THD looks fairly respectable at 0.043% THD. We've now increased the output to 1 volt, which would be about the average. Obviously, I can't say specifically because I don't know what amplifier sensitivity you'll be running this into. But as a ballpark figure, this would be kind of normal listening level. And here you can see the distortion has gone up quite a bit. The little bit of mush you see here, by the way, is not part of the distortion. It's an anomaly that we get whenever we measure distortion, and it's something odd about the quantisylum, so ignore that. As we go up in level, we are now producing 1.5 volts output from the preamp. That is a pretty good loud listening level for many amplifiers, but distortion now has leapt to just under 2%. One of the things that I found not surprising, but something that you can pick up in particular, is the crosstalk. That's the difference between the left channel and the right channel. And I'm surprised it's as bad as it is, bearing in mind that each valve runs one channel. But I think the poor crosstalk is largely because of the board layout. There's not really, you could get a bit of cross feed from the type of power supply that's given insofar as they're not decoupled from each other. But I've got some figures here that I've measured. Now it's fairly hard to get an accurate figure on this because the noise is so high in the form of hum and to a lesser extent hiss. Now it's normal to measure the crosstalk usually at 1 kilohertz, so I've done that. It's only minus 36 dB, which is, if you compare it with our amplifier, it's really poor. But it gets worse. At high frequencies, at 20 kilohertz, you could argue that's extreme, but it drops to 18 dB, minus 18 dB, which is incredibly poor. The effect of that is that the sound doesn't appear to have a good sound stage. That's the only real way I can describe it. Everything seems a bit muddled and you can't define where the various instruments are. You'd expect the crosstalk to be in excess of 90 dB at any frequency, but ironically it's no poorer than you get from an LP record at any frequency. So it just goes, old analog stuff is really not good. Whatever you do with it, it really isn't that good. This requires a little bit of an explanation. It's dancing about a little bit because the scope is DC coupled. What you can see there is the noise floor with the volume pot on minimum. You can see here the fundamental of roughly 50 Hertz. The scope's having a bit of a trouble syncing to the frequency because of all the noise, and the spikes you can see is actually noise. And to be fair, I do have the gain on the scope pretty high, basically not to shock you but just so you can see it. So I'm going to turn the volume control up now, and you can see now the noise itself is higher, but the 50 Hertz signal that you could see on there is, I won't say gone, but is diminished. And by careful manipulation of the volume control, see it's back again there. But if I turn the gain on to full, you can see hum superimposed on the noise. And that's with the input short circuit, by the way. So there's no stray signals, and I've got everything earthed, including the pot casing, because when I touch the casing, the noise goes up. So I've actually got an earth lead strapped to that. Just for giggles, this is what happens when you tap the valve. That's microphonic, and that's not particularly because of this circuit. Most valves are microphonic. The overall sound is surprisingly good for what it is. I think it all goes back to the usual thing. For the money, it's very good. I can't help thinking that the thing that lets it down is the noise level, crosstalk, but mostly hum. It's not buzz. So that's what would stop us both using this. I'm not saying that all valve amplifiers aren't good, but this is a very, very simple circuit. It suffers from virtually no negative feedback, And valves are unlinear devices. You need feedback. The circuit isn't good enough, and the layout of the board isn't good enough, and the valve isn't good enough. You need a proper audio valve to really get good quality, and this isn't one of them. It's actually an RF pentode, so it's not a good audio circuit. As per usual, thank you for watching. Goodbye for now. I'm returning to the dark side.